What is a model eliciting activity? It is used to encourage students to use their knowledge to create new knowledge. So the idea is making learning more student-centered, and to accomplish this, you need to create model eliciting activities. Model eliciting activities require students to quantify information. An example of this is that students are given graphs to quantify crystal sizes using micrographs. There are 6 design principles of MEAs. The first is the model construction principle. So an activity developed requires students to create a mathematical system to address the needs and purpose of a client. The second is a reality principle. So the question posed in an activity has to be a realistic engineering situation and requires a mathematical solution. The third is generalizability principle. So the questions you have to ask is, does the model provide ways to approach a situation that is shareable? The fourth is the self-assessment principle. So the problem provides context and information needed to help students evaluate their progress as they work on a problem. So engineers have to reorganize the concept, but it allows for explosion of ideas to occur, such as brainstorming. The fifth is construction documentation principle. So that means that activity is not only model eliciting, but revealing. And what this means is that the activity is designed and encourages students to externalize their way of thinking by recording meeting steps and solutions. The last principle is the effective prototype principle, which means student solution provides a metaphor or a prototype to interpret other situations, and the model could be used in different situations. Using MEAs encourages students to think and encourages us to think about how students will learn. So there are 4 different principles that guide people how they learn. First is knowledge-centeredness, which means the students want to learn just for the basic of acquiring new knowledge. The second is learner-centeredness, which means there's a focus on students and how the students learn. A third is assessment-centeredness. Students are driven to perform well on tests, so they will study and work hard to do so. A fourth is community-centeredness, which means that the community or the surrounding environment of the student encourages learning and thinking. So what are some MEAs? There are some examples in first-year engineering classes at Purdue where they do different things in which the activity requires them to use normal engineering solutions that is used in the real world. One of these activities is that teams will get into 45 to 60 minutes and they'll write a memo to a client that explains their mathematical model and forces them to compare their method to the method engineers currently use. Because MEAs are not traditionally used before college, there are some challenges as it offers a new way of thinking. So some of the challenges from the teachers and the TA's side includes creating appropriate context and limiting problems within that context. Another appropriate challenge, or another common challenge I should say, is because this is a new way of thinking, and because it's a new way of thinking, students are fairly uncomfortable with it because they're always taught that when doing problems, there's always a right answer. Because these problems are very open-ended and these activities are very open-ended, there's no one right answer, which is very different from traditional way of thinking and teaching in K through 12. Also, because these challenges or these problems are relatively new, they should be introduced earlier in education, which is difficult because K through 12 have a very structured education system. A solution to this is adopting engineering-based MEA activities for students as early as middle school so that they can be exposed and that they can use these opportunities to develop their critical thinking skills earlier on.